Hello everybody, so I will start my today's coding practice. So today's question is this one. So case register element in an array, and this is my third video for this question. And if you remember, yesterday I solved this question with mini heap of max size k. And it was my first video. And then in my second video, I used the quick select approach, and I introduced how I can do quick select in that video. And today, in this video, I will introduce the count sort approach to solve this question. So let me get started. So quickly I will raise the question. So giving an integer array nums and an integer k returns the case register element in the array. And note that it is the case register element in the sorted order, not the case distinct element. Can you solve it without sorting? Yeah. Okay, so let me go with this example. So with this example, I will find the false register element. And let me rephrase this with fifth smallest element, because as an engineer, it is the most intuitive, and I can avoid the errors by thinking of the zero indexed count. So that being said, what I will do is find the fifth smallest element from this array, and obviously let me quickly sort it. It will be sorted in this way. So the fifth smallest element is 0, 1, 2, 3, 4, 5, which is 4. So I will return 4 in this question. Okay, so let me take a look at the constraint. So here I can find that the nums range is from 10 to the power of 4, negative 10 to the power of 4 to 10 to the power of 4. And also, the good thing is the element is integer. So what I can say is the possible range and possible values which num can take is limited. So that's a good thing. And so what I can do from here is, firstly, I will take a look at each num and find what kind of number appears actually. So in this case, the number which appears is only this. Then what I should do next is how many times each number appears in the array. So 1 appears only once, 2 appears twice, and 3 appears twice, and 4 appears only once, and 5 appears twice, and 6 appears once. So this being said, what I can tell from this is, thinking of, say, only 1, the number I've seen which is smaller than 1 is only 1. There's only one smaller element. But when I think of 2, there are 3 smaller elements. When I think of 3, there are in total 5 smaller or equal elements. when I think of 4, yeah, there should be 6. So simply saying I can get the prefix sum to get the number of smaller or equal count. So that's the basic approach of count sort. And one thing which helped me to use this count sort approach is that numbers are integer. So because numbers are integer, the appearing number is limited. Yeah. Okay. So that being said, let me tell you how I can, implement this. So the first thing I will do is so I'd like to know the unique numbers which appear in this array in a sorted order, or I can do something like so because I have this 3, 2, 3, 1, 2, 4, 5, 5, 6. When I find 3, it appears twice. And let me see. Yeah, so I think actually there is a possibility that the number is more sparse like this, and in that case, even though the concern of the numbers is this, I still, to avoid sorting this, I have to, think of every number which is in the range and then put numbers here like this. So that being said, yeah, let me quickly think if I can avoid this problem. No, I have to sort to avoid it, and it will take n log n. Okay, so let me do it in the way that I will have for each possible number there is a throat for that. Okay, so because it appears to be the number can be negative, I will prepare the throat in this way, and when I find the number I will increment that throat, and finally what I will do is traverse the number array again and find the position where the kth smallest element exists. Okay, so let me quickly tell you about the complexity analysis. So for time complexity, assuming that the number array is n, it should be n And also, because I have to create the whole kind of slot array whose ranks is in the range of every possible number. Yeah, so this should be the time complexity, because firstly I will traverse each element and put it in the slot of the whole numbers array, frequency array. Then I will kind of traverse that frequency array from the beginning, and that's the time complexity I have to take care. And also for space complexity, because I have to, it is possible that every number should appear. Oh, sorry. So space is exactly max m minus min n, because this is for the frequency array space, and aside from that, I don't need any space. So this is the space complexity. Okay, so that being said, let me start the implementation. So but as long as I use the default dict, no, please forget. Yeah, I thought this wouldn't take that much space, but when I traverse the default dict, if the key doesn't exist, it is created. The key is created with value 0. Probably I can optimize it, but let me think of it later. So let me convert it to case smallest. So it should be case smallest is, seems like I can get it with n minus k. So yeah, if there are 9 elements, and if I'm looking for the first largest, it should be the eighth index 8. So yeah, 9 minus 1 with tail correct. So I'm pretty sure this is correct. And from here, I will put this. Then in the end, what I should do is traverse from the mini number to largest number. So sorry. Okay. So so for each number, I will take a look as the frequency of that number count. And what I should do is I will make sure that the next index is ever starts from 0, and I will append the count here. So what happens is that if I'm looking for index 0, I mean 0 smallest number, and if this next index is 0, it still hasn't occurred. That number still hasn't occurred because 0 is the next index. But when the next index is more than 0, like 1, which means that index 0 is already visited. So exactly after updating the next index, I will check if this exceeded the case smallest, which is what I'm looking for, and if next index exceeds that, I will return current num. Yeah. And here, if I finish the loop, which means that the case largest doesn't exist. Okay, so let me quickly check my code. So in line 34, I initiated the default dict of num frequency. And then from line 35, I increment the map with numbers which appears in the array, and in line 39, I will start the traversal for the min number to max number, and every time I update the next index, and if it exceeds the case smallest, which I'm looking for, then I will return the current number immediately. Good. Sorry, this is typo. Okay, then I will submit my code. Good, it is now accepted. Okay, so a small optimization I can make is that instead of traversing all the numbers, firstly I can say I will look for the min number and max number which appears. I will keep track of them while I'm doing that iteration in line 35, and then I will do that range, do that, I will traverse the numbers which are in that range only. So let me quickly do that. Good. And also another thing I can optimize is the space complexity. So in num frequency map, this is a default dict. So every time I look for the number in line 45, the new element key value pair num to 0 is created if it doesn't exist, if the key num doesn't exist. So instead of that, I will use the hash map here. So let me update the code. So in this way, number frequency, sorry, is, I mean increment the number of number frequency. Then in line 47, if num so what I can do is, if the number doesn't exist in the frequency map, I can just continue because I don't have to take care of that number. Yep. Good. Okay, so I could solve this question with count sold. So in this way, the space complexity is now number of unique element, which is exactly O of n. Yep, good. Okay, so let me quickly wrap up. So for this case largest element in an array question, in this video, I solved this question with the third approach, which is count sold. So I could use the count sold because each element in this array is integer. So yeah, actually it doesn't matter. No, it matters. Yeah, because if element are integer, I can just traverse the integer numbers in the iteration. I don't have to take care if I cover all the numbers in that way in iteration. Yeah. So because elements are all the integers, I can use the count sort approach. And the key thing here was that I created the frequency map of numbers. Then I will traverse each possible number from the smallest one to the largest one. Then I will check the numbers I've seen so far exceeds k, which is the number of element I'm looking for. So, and if it exceeds, I can return that number, current number. Yep, so that's the basic approach. Okay, so let me finish my video with this. Thank you.